business continuity. In this nugget, we'll be discussing business continuity, which is really making sure that your business continues to run. We do that by doing a few different things. One of those is by implementing network load balancing. One of the ways to keep your business running is to keep your customers coming in. And in a web-based environment, that could involve having web servers that are highly available and that perform well so that users don't get impatient with it. Well, you can use network load balancing for things such as web servers. That's a very good use of a network load balancing. And we're going to be talking about the details of that, but specifically, we just want to have multiple servers that will be able to perform the same role and balance that load. It's also a form of clustering, but clustering proper, as I call it, is where we actually have two or more nodes that can also give us a high level of redundancy and failover. And that way, if one of the servers fails, one or more of the other servers can pick up the slack. Then we also have operations masters. You could do for a brief period of time with some operations masters that could be offline for a little while, but a lot of them are pretty critical. And if the operation master goes down, you might not be able to do things such as create new accounts or be able to have certain applications work properly, a lot of different things like that. So you need to make sure that they are highly available. I'll talk to you about how to transfer them to other servers if you have another server that's more capable, and also how to seize the role in case the original role holder is no longer available. Did you ever have to ask a friend to help you move? I think that you don't actually qualify as a friend unless you've actually helped the other person move at least one time. I've got a friend of mine in Iowa. My wife and I and my family used to live in the Midwest, and we've moved multiple times while we were in the Midwest. And one of my friends, his name is Tim, he's also my accountant, he's helped me move, I don't know how many times, like 4 or 5 times. And then when he moved, I happened to be out of town. It was quite convenient, actually, but he never ceases to tease me about the fact that he always has helped me move multiple times, and I've never helped him move even once, so I guess I'm not a very good friend. But it certainly is useful if you have more than one person or more than one system to be able to fulfill a role and help to balance the load, and certainly network load balancing is no different than that. Network load balancing is like having another computer friend that can help to shoulder the load for the network services. And with network load balancing, of course, you have to have 2 or more nodes in order to be able to make this work. And this is, of course, something that we're probably already familiar with at this level, but just as a quick review, let's identify what really goes on here. Well, of course, we have 2 or more nodes that have the same role. So most commonly, you're going to see this kind of thing for maybe a VPN server or a web server. But these 2 different nodes actually have 2 separate and distinct physical IP addresses bound to their network cards. Okay. However, once you configure network load balancing with these 2 or more nodes, they're going to be seen on the network as a single IP address and MAC address. And this is going to avoid, the fact that they'll have the single MAC address is going to avoid the erroneous network error that you have duplicate IP addresses on the network. Okay, and that's one reason why that takes place. The emphasis here with network load balancing and the advantage of it is mainly for performance. Yes, there's also some redundancy there or some failover capabilities, but the emphasis is usually going to be on screaming performance. And let's also take a look at where you might use or implement network load balancing or the usefulness of it. First of all, you can use it for stateful or stateless connections. And if I think of maybe a web page, let's look at it that way. And in fact, that's one of the usefulnesses of this. Usefulness is that a word? Anyway, stateful might be where I make a connection using a web browser to my network load balancing web server. And it also has cookies and on the client side that have to reconnect to that original server that I made the connection to. Well, that's a stateful connection. So if I have additional business that I need to conduct with that server, then I need to make sure that I connect to the same node and not to a different node in the same network load balancing cluster. Likewise, maybe I have some kind of an online transaction that I'm performing. Maybe I'm purchasing something, and I'm making an HTTPS connection. Well, again, when I click next, finish through my wizard that allows me to buy something and enter in my credit card information and all of that, I need to make sure that I stay with the same server, so that's going to be stateful information as well. On the other hand, I could use stateless information. This might be the case where I have just static web page that only provides information. And if I click on one page, it doesn't matter if I click on a link to a different place on the same website if it's served by the same server or not. That would be stateless information. Then I also could use this very useful for a virtual private network. And the key here is that we don't have any kind of data change with any of this, and we'll talk about that here in a little bit. But with something like a VPN, I just need to be able to make a connection to any VPN server in the network load balancing cluster. Now, as I'm talking about clusters, let me also clarify something here. We do have the clustering service, which is kind of a different thing than network load balancing. Sometimes we use the word cluster when we refer to network load balancing, and Microsoft documents it that way, but you don't want to get the two confused. Here, network load balancing is going to be distinct from the clustering service per se. So anyway, we can also use it for ISA. So maybe you've got 2 or more ISA servers on the network. Well, when I go out to the internet to fetch web pages, I don't really care as a client which ISA server I use. I just want to get to one. And I want to have high availability, and moreover, I want to have good performance. Well, I can put ISA in network load balancing. Terminal services, that's another good example of where I'd want to use network load balancing. And the key thing here is, for these types of services, you don't want to use network load balancing for anything that has changing data. For example, a mail server. I didn't list that there, but a mail server, a SQL server, a file server, anything like that, you don't want to use network load balancing for. Those are much better services for something like clustering proper, or the clustering service. So let's take a look at this figure here to get some more of a conceptual idea for network load balancing, or just as a quick review if nothing else. And also let's compare how this works compared to round robin, because they're very similar in some respects. So for example, let's assume this whole scenario is actually round robin. Then what would happen here is I might have my workstations here, and they're trying to access a web page, www.nuggetlab.com. Well, what goes on here is, if I was using round robin, I would set up an A record for each one of these servers, and the A record would identify each one of them as nlb.nuggetlab.com, but each of the A records would have these IP addresses in each one of the A records. Then what would happen with round robin, of course, is that this one would respond possibly first to the first client workstation that queried. And then this one would reply second, then this one would reply third. Then the next go around, this one would reply first, this one would reply second, this one would reply third. And the next go around, this one would be first, this one would be second, and this one would be third. Okay, so you get the idea there. It goes just like the ping pong game of round robin. The problem with that, though, is that it doesn't really give you any kind of failover or redundancy. I mean, if this server went down, or we took it down for maintenance, or we were performing an update and had to reboot it, whatever the case might be, if my client, if it's this server's turn to come up now, that's supposed to be number 1. If it's this server's turn to be number 1 and answer a query, well, guess what? The client down here in their web browser is just going to time out or say, unavailable or something like that. Whereas network load balancing, it works with a pulse, so that if this doesn't respond within 5 pulses, and it's usually 1 pulse per second, so 5 seconds, then it will remove this from availability for the network load balancing cluster, and it will make only these 2 available until this one comes back and starts sending out a pulse again. And of course, I'll use network load balancing, an interface. There's an MMC console for it and everything there to configure all of this. But then on the DNS side of things, what I'll do is I'll have a CNAME record for www.nuggetlab.com. It'll point to nlb.nuggetlab.com, and then I'll have an A record for nlb.nuggetlab.com that is has an IP address of 10.10.10.64. The 10.10.10.64 is the network load balancing IP address, and so now anytime one of my workstations tries to, once it's resolved the name, once it tries to contact the web server, for example, it'll go to this, resolve to this IP address, and then one of these network load balancing servers will answer. Let's go ahead and take a look at my clients, or rather my DNS server here. Here I've got my alias record, or www.nuggetlab.com. And if I double-click on it, you see here that it points to nlb.nuggetlab.com. Well, what's nlb.nuggetlab.com? Well, that's a host record that I created here that points to 10.10.10.64, and you can see it right there. Okay, not a whole lot fancy there. That's just what it is. And then, of course, I've got an IP address also for each one of my network load balancing hosts right in here, but those don't really matter for network load balancing purposes. These were just registered. What really matters, though, is that it's pointing to 10.10.10.64. Now let's go ahead and take a look at how I might configure all of that. Here I'm on Network Load Balancing 1 or nlb1.nuggetlab.com, and I'll have the Network Load Balancing Management Client. I guess I should show you where that is on the Start menu, but it's under Administrative Tools, and then Network Load Balancing Manager. Okay. If you don't have it, just add it as a feature from Server Manager. Now, once I've got that going, there's nothing really to show yet. There's nothing to expand because I haven't created my cluster, so I'll right-click here to choose a new cluster. And I'll go a little bit quickly through this because, again, at this level, we're mostly just looking at this for review. But my host there is going to be, I got to point to one of the hosts that are available there, and that'll be nlb1.nuggetlab.com, for example. And I'll connect that one. And then I have to identify which IP address it is that I'm interested in connecting to. Now, I've got 2 network adapters on each one of my network load balancing servers because I may also want to use those for clustering later on, but I only really need one for my current purposes. So I'm going to go ahead and click on Next to use the 10.10.10.61 address. Then I've got a priority here. This means that at priority 1, this particular host will respond to any requests that don't have a protocol rule of some kind. Okay, so we'll go ahead and leave that at 1. Okay, and then we can go ahead and click Next, and then we can add in here any cluster IP addresses that we're using. In this particular case, we're working with just one website. If I had multiple websites, I might have multiple IP addresses I needed to enter in here. But I'm going to enter in 10.10.10.64 with the Class C subnet mask. Okay, and of course you can also use IP addresses for IPv6 here as well, which we discussed in a previous nugget, but that's where you would enter that in if you wanted it to respond to those addresses as well. Once you've entered in the cluster IP address, this is of course the address that my web clients are going to try to work with. Then what we'll do here is to enter in the full internet name of this IP address, for which I've already put an entry in to DNS. That'd be www.nuggetlab.com. Okay, and then of course once again, if I had additional web servers, www.accusource.net, www.cbtnuggets.com, whatever else, then I would have additional IP addresses configured on the previous screen that I would use for that. And then, of course, you can use unicast, multicast, or IGMP multicast. And just in quick brief here, unicast is going to be where it's going to be stateless and where it might connect to multiple web servers to serve up different content from the web pages, but I might use multicast if I wanted to dedicate a communication from one client to one host in the network load balancing cluster. Okay, and that's what I would do again. If, for example, if I had some kind of a secure transaction or I had cookie tracking going on, something like that. IGMP multicast is just another form of the same, except that this will avoid switch port flooding, because multicast could go out of every port on a switch, whereas IGMP multicast would not allow that to happen. It would only send the communications out to the appropriate port that communicates directly with the designated host that's supposed to be communicated with. Then here's our port rules. Right now it's responding to everything, but if I wanted to lock this down a bit, I certainly could. If I knew that I was only going to work with web hosts here, for example, I could set this up to 80 only. And if I had secure connections, for example, and I was using port 443, then I could add that in here as well. And then I can specify which protocols we're responding to, TCP, UDP, or both. And then for filtering mode, we have here multiple host. And this is simply going to identify that I have multiple hosts in this cluster that are going to handle the specified port rule that we're working with right here. And then later on, I can also specify, and this is another advantage, by the way, of network load balancing over round robin, I can also specify the load sharing distribution. Like I might want one server to handle only 20% of the load, but another server to handle 40% of the load, and another server to also handle 40% of the load. So I can specify which servers get more or less of the load if I want to. On the other hand, if I had chosen single host, then only a single host would be receiving any traffic associated with this. So, if I had only one web server in the network load balancing cluster, then, this might be the case here, where this was only responding to one. If I had, some other kind of service in there, then I could set that up on a different port range for a different host to be able to respond to. Then finally, I could disable this port range, which would be kind of somewhat essentially the same as using kind of a rudimentary firewall if I wanted to do that. So anyway, I'm going to cancel that because the default will be multiple hosts here anyway, and I'm going to just leave it the way we see it right here for the time being. And then when I'm done, I just go ahead and click on Finish, and we can see here that it's starting to try to build up that network load balancing cluster. Now I'm going to also go up here, and I'm going to add another host to the cluster. Now, that's just going to be nlb2.nuggetlab.com. We'll connect that one, and I'll choose, again, one of the network interfaces here at .62, and then we'll just click on Next. This one's going to be unique host identifier 2. This would be second in line to service all requests if this server were not available, for example. Okay, and then again we have our defined port rules, which we've already looked at, so I'll go ahead and click on Finish here. Now, what we'll have here is, once we get both of these synchronized up, we're going to see that they will both be converged, which means that they'll both equally be able to service our network clients. All right, so that was that. Now they're both, converged. I can also add a third one, fourth one, fifth one easily from here if I wanted to. By the way, one thing to notice about this that's different is that in the past, in Windows 2000, for example, you would go to the network adapter's properties. Let's go ahead and take a look at that. We'll still have network load balancing as an option there. Okay, when I go to my network connections. But you don't configure it from there anymore. It used to be that we would configure it from that location. So you'd go to network load balancing and then hit properties. Well, look, you can't do that anymore because it's now all handled through this interface now. We used to have the same interface in Windows Server 2003, but we didn't configure it always through that. We sometimes would configure it through the network adapter. So, other things we can do now are to go to the properties of this host, for example, and I can go into the port rules, and if I click on Edit here, then I can say, this is where I was telling you earlier, you might want to adjust the load weight. Maybe Network Load Balancing 1 has only one processor, but Network Load Balancing 2 has two processors. So I might want to give it a lower load weight. Maybe I want to give it 25% or something like that, and give the other one 75%, something like that. So just a couple of different options there that you can use for determining the balance. Now let's take a look at the other kind of clustering, which I often just refer to as clustering proper so as not to confuse it with network load balancing, which once again is also a form of clustering. But this would simply be a server cluster, also known as Microsoft clustering. Now when you actually work with this, from the Administrative Tools Start menu, it's also changed names a little bit now from Windows 2003. It's now called failover clustering. Anyway, what we have here is two or more hosts. Of course, that's the purpose of redundancies. You've got to have more than one. Now, what we have with this also is, again, we have different IP addresses for each one of the hosts. But on the net, once again, on the network, they're again seen as a single IP address. And let's go ahead and take a look here at DNS for nuggetlab.com, where you can see that I've kind of revised things here a little bit from my network load balancing configuration. And now I've got two hosts, a cluster 1, a cluster 2, and then I've also got another host here called cluster just cluster, and that's going to be at a different IP address here. So we got 61, 62, and 64 going on there for our IP addresses. The other thing that's distinctive about a server cluster is that it has common data. This is something that we don't have with network load balancing, where they all have their own independent hard drives, for example, in a web farm. Now, if we did have a change to the website, we would have to figure out a way to copy that new data to every one of the members of the website, of the web farm, and there might be some kind of a script or something like that where you can just copy it all over, or maybe you have some other third-party automated solution. But otherwise, here with the server cluster, what we'll have is shared common data. So you have two or more servers that actually have a physical, or most of the time it's a physical connection, but it's now changing very often to an iSCSI connection or a SAN connection or some other kind of connection, but it is physical data that they share. Okay. And then also the big emphasis with a server cluster as opposed to network load balancing is not performance, although you do also get good performance. But the main thing here is availability for failover. So that if one of the servers goes down, it's virtually completely transparent to the client that that server's gone down. Now they have another server that will take over instead. And then the other thing here with the server cluster for its usefulness is we are able to use dynamic data. That's why, since we have shared storage data there, it's still not going to be that you have two or more servers most of the time, and in most contexts, accessing it simultaneously. Very often, for example, you'll have an active-passive solution, where, for example, maybe I've got a SQL server that I'm working with here, and I have one server connecting to that SQL database on a normal, everyday basis, and that's what everybody's really using. But then here is my passive. This would be my active one. This would be my passive one. And the passive one also has a connection to it. It's just not using it. It's just burning electricity most of the time and really pretty much doing nothing. It's passive. However, if this active one is either down for maintenance, on scheduled maintenance, or if it just, starts to catch on fire and burn up, well, the passive one, which may even be in a different server room somewhere, can still provide service for us, and it now becomes the active node that we have there. So that's just one, kind of chicken scratch example of how that works. And because it works with dynamic data, it's very common for Exchange or in a kind of a mail server, a file server, SQL, as I just mentioned there, DHCP, WINS, print servers, all different kinds of things like that. And again, most of the time, you're going to use server clusters with something that has dynamic or changing data. All right, here I've got a little diagram that hopefully will bring some of this to light as well. And again, at this level, you probably already have some understanding of clustering, but this will be, if nothing else, a review and give us a sense of context. Here again, we have at least two cluster nodes or members of this cluster. And what we also have is stored or shared data right here. Okay, this could be anything from a SCSI cabinet where we both hosts here have a SCSI cable connecting to the same SCSI cabinet, and we have multiple drives within it or multiple partitions within a RAID array or something like that. Also, the data here, usually all of these, is also going to be some kind of RAID as well. So, maybe the witness or the quorum drive is mirrored. Maybe this data is RAID 5, something like that. So this might be a RAID 1. That'd be mirroring. This might be RAID 5. Oops. Just anything like that. Okay, because usually this is also redundant as well in some respect. And then, of course, it's usually also backed up, and that's a whole other story. And then usually you'll have a spare drive, one or more spare drives, so that if maybe one of my RAID 5 members fails, then we can supply this instead. And there are a number of different ways of doing that. Some of them are fully automated, so that if that one of the drives fails, you get a notification probably as an administrator, but the spare just automatically goes in. Or you can just plug it in as a hot spare on your own. Usually this kind of redundancy, you don't have to down anything or anything like that. You just plug the drive in. And with SCSI or even serial ATA, it'll just immediately start working and rebuilding the data. Okay, enough of that though. So what we have here is both of these are connected, as I mentioned, and then on our networking side of things, we have two network connections. You can use adapter teaming for this kind of thing, but one of the recommendations that's kind of a common recommendation is that you actually use separate network cards, because we'll have one connection to this network here and another connection to this network here. It doesn't have to be these IP address ranges. That's just what I'm using in the illustration here. And this one is going to be kind of the public one where my workstations also connect on the same network. And then when they want to access the file share data, or their, maybe these are Exchange clusters or something, when they want to access, their mail or whatever it is, then they'll do so on this subnet. Well, what's this subnet for then? Well, this is for these two cluster hosts to have dedicated communication. This could very often be a VLAN. Okay, or if you're using virtual machines, this could be just some kind of a dedicated network, which is what I'm using. Some kind of a dedicated network there that no other hosts communicate on except for the cluster members. But the purpose for this communication right here is for heartbeat data, so that both of these cluster members can be aware of the fact that each one exists. And if this cluster here, goes down, there's heartbeat. There's no heartbeat anymore, so the cluster 2 here will spin up and immediately take control over all of this storage and service the clients. And the reason why our clients, of course, don't have to be concerned with whether or not they're using cluster 1 or cluster 2 is because they're just connecting to cluster, at least in the case of my DNS, the way you saw me have it configured. And when it fails over, then it just is very transparent to the users. Also, when we have this, we have one disk that we can't really do without. And this one is called, in previous versions of Windows, it's been called the quorum, and it's probably the most common name for it in other clustering implementations as well. Microsoft and a lot of other clustering implementations are now starting to call this the witness instead, which I think is kind of actually a little bit more of a descriptive name, because the witness contains configuration information about this cluster, and it kind of is the the authority on how this cluster is supposed to look and be configured. And if this cluster server goes down, this cluster server here has to be able to communicate with the witness to be able to confirm the proper configuration of the cluster and what disks are involved and so forth. There's another thing here as well, and this is just really probably more than we need to know for our current purposes, but I'll just share it with you anyway. Normally, one of these is active, like I said, maybe this is my active one, and this one might be passive. But there's also an active-active solution, just FYI. However, you still don't want both of these hosts accessing the exact same data at the same time, because you could really run into some synchronization problems with that and some data inconsistency. But let's say that we're running SQL. Okay. With SQL on both of these, we can actually have both of them be active and kind of split the load up. So maybe my data here is maybe that we work on West Coast data here. Okay, maybe this is my West Coast SQL server, and this is my West Coast data. Maybe all the clients on the west side of the Mississippi are going to be accessed here. On the other hand, here I've got my East Coast SQL, and maybe this data here is my East Coast client list on my SQL database from the east side of the Mississippi. So now what I have going on here is any time I need to access East Coast clients, I do so using this SQL server and East Coast data. West Coast clients will be through this West Coast SQL server and this West Coast data. However, we still have failover as well. Let's say that something happened to the West Coast SQL server. Well, what happens is this is not always just only active for the East Coast. It's also, I'll put it kind of in parentheses here, it's also passive for the West Coast SQL. Okay? And this one over here would have been passive for the East Coast SQL data. And so then if this one fails, now this one, which had been passive for the West Coast SQL data, now becomes active, and now it's shouldering the whole burden for both coasts and shouldering the burden for both sets of data, but at least we don't have an outage. Another thing that's involved in this, and I think I have a whiteboard for this as well to describe this a little bit, is that these may also be geographically dispersed clusters. And the way this might work with a geographically dispersed cluster is that each site will still have its own member nodes. So on maybe the East Coast is New York, and it has a cluster member there. And my West Coast is Los Angeles. It, of course, also has a cluster node there. And then we also have our common storage in each site. Wow. That would have to be the case just about, because how are you going to make a SCSI cable long enough to connect both the East Coast and West Coast, like 3,000 miles long? So how can that happen? Actually, there's a lot of infrastructure possibilities that go beyond the realm of Windows where that could take place. You might have a data center in Denver, maybe partway through, that has some connectivity to both coasts and to both offices that's using other methods. There's all kinds of SAN storage methods that could be used and so forth. But again, that's all way outside of the realm of Windows. The other thing that could happen, however, is that you have storage in each site. And let's go ahead and take a look at that. And I've kind of copied and pasted my diagram here for that purpose. Here, this is Los Angeles, and this is going to be New York. Okay, my West Coast, my East Coast. My Los Angeles office, it has all the storage data there where it's locally connected through a SCSI cable, or this might be also SAS, which is serial attached SCSI, or fiber channel, or iSCSI. I've been using iSCSI lately, and I'm pretty happy with it. But anyway, for smaller implementations anyway, and it's all connected here. However, on the New York coast, we can't make a SCSI cable long enough to connect clear over to the Los Angeles office. So we've got our own connection. Ooh, that was crooked. But we've got our own connection here to our own data here. This data is mirrored with this data over here. Now, how do you mirror that? Well, there's a number of different ways, again, of doing that as well. And it depends on, WAN speed. It's going to require some WAN connections and so forth to keep that mirrored. But anyway, we have the same data in any case. So then, if this again goes down, then we should have pretty close to the exact same data over here that's been mirrored in the New York office, which can then take over for the Los Angeles office. Let's go ahead and take a look here as well. Like this again. Okay. So again, we have common storage that's mirrored in each site. The redundancy here is again going to be for node failure. That's kind of one of the main things with clustering, but also for WAN failure. So for example, if I normally have, let me get rid of that. If I normally have my New York clients that normally access only East Coast data, but sometimes they need to look up a West Coast client, well, they're of course going to have to go across the WAN or whatever it is to the Los Angeles SQL server, which will then also reference that data. But if the WAN link went down, and let's say this was it right here, if the WAN link went down, then they would only be able to access the local data here, and then they would do that through the New York office. And of course, there's a lot of different ways of configuring that, and there's possibly some inconsistencies even in what I've described. But the main point of this is that we can have a geographically dispersed cluster. But as we get back to our whiteboard here, one thing you really got to consider with this, and that was kind of what I was talking about just then, was the WAN traffic. You might have really fast links, you might have some kind of an OC3 connection or something extremely fast, but you still have to consider that there's going to be a lot more WAN traffic in a geographically dispersed cluster. Now, another thing I'd be aware of for exam purposes is the fundamentals of a cluster upgrade. This, again, is a multi-step thing that you would have to go through, but you do need to be aware of just some main kind of bullets with this. First of all, in reality, this is actually a clean install because you're going to be installing the operating system clean on the Windows Server 2003 server that you want to upgrade to Windows Server 2008. The part of it that's really an upgrade, though, is the cluster data is still using the same quorum. You don't really upgrade that, so to speak. The data is all going to be the same. So the operating systems are installed clean, but the cluster still got the same quorum data or the witness data and so forth. Also, this is normally going to be in an active-passive scenario when we take a look at this. The way you'll do this is you want to stop the cluster service on the passive node first of all, and then once you've done that, you want to evict it. So if we take a look at our diagram here, for example, I'm in an active-passive environment with Windows Server 2003 on both of these. I'll leave this one running so I can still have service to my clients, but this one, I'll stop the cluster service and evict it. Okay, so it's no longer available for that kind of purpose. Then what I'll do is, we go back over here, is I want to install Windows Server 2008. Then I will join the cluster. Okay, so once I've installed Windows Server 2008, I then join the cluster, and then, I'm back in business. Once I've joined that cluster, if I want to upgrade that one as well, and I probably do, I'll make this one the active one, make this one the passive one, then I'll down the cluster service and I'll evict this one, and then I'll do the same thing. I'll upgrade this to Windows Server 2008, and then I might make that one the active one, and then this one the passive one again, if I want to. Okay, so it's just a matter of doing it that way. Basically, the way we're doing this, we're just kind of playing a shell game and protect the witness and all of the data, so that we only upgrade one of these at a time, and that we always have service continuing to provide access. And then quickly going back over here, if you need any step-by-step steps for doing such a thing, you can look at KB article 842-427. As an FYI, you can just locate that on Microsoft's website. This article actually refers to upgrading, I think, from 2000 to 2003, but the steps are pretty much the same, so it doesn't make much difference in that respect. Oh, let's go ahead and take a look now also. I'm going to just show you the interface for some of this so you have a sense of context, and you'll see what the cluster might look like and how to make some of the basic connections. All right, now I'm going to just take us through a kind of a quick rundown of clustering some things together here. For specifics of all of the steps that you might want to see for this, you can take a look at the 70-643 exam pack, which is forthcoming from CBT Nuggets. And I should be recording that series here as well. But for just kind of a quick rundown, I'm going to go here to Cluster 1, where I haven't configured anything yet. I've just installed failover cluster management, which you do as an added feature in Windows Server 2008. Once we've done that, we've got a little bit of a different interface than you might have seen in previous versions of Windows. One thing you might want to take a look at here is there's very good README and help information over here to the right. But also, you can validate a configuration in advance, and this is very useful because if you pass with flying colors, then Microsoft will support you in your 5 nines objectives, because normally that's one of the goals of clustering is that you want to maintain at least 5 nines, which is usually about only 5 minutes of unplanned downtime per year. If you don't successfully pass and you are left with some warnings in your validation, then what could happen there is that Microsoft may not fully support you. and you may have some legitimate problems there with your setup. In fact, in my case, I probably will have some cautions, but a lot of that relates to the fact that I'm using virtual machines and not entirely using physical hardware. Also, I'm connecting using iSCSI, which is a way of attaching network storage to your system, but your system will see it as a SCSI interface, and therefore you'll be able to format the drives and store data on them as if they were local drives. Okay, so without any more talking here about that, let's go ahead and take a look at validating a configuration. As we take a look at that, we'll see that it'll do things such as check our storage, see if it's suitable for clustering, check our drivers to see if they're stable, and so forth. So we'll just click on Next, and I'll just go ahead and add in a server or two here, cluster1.nuggetlab.com. Add that one in. And then I'll also add in cluster2.nuggetlab.com. And you'll just add in the ones here that you intend to be members of the cluster in advance. Then we'll go ahead and click on Next, and you can just run all tests, and I'm just going to go ahead and do that for the time being. You can also deselect certain items if you want to have it go through all of those a little bit faster. I'm probably going to get some little red characters in here. The red, of course, means bad of some things, but overall, it should still be able to work for basic demonstration purposes. And then when the test is completed, you'll see either a green check or a cautionary symbol like you see here, or a red X. If you get a red X, you can't install it at all. If you get a symbol like this, you could probably still install clustering, but it might not work, or Microsoft won't support it fully either. You can also view a report here, which opens up an HTML page. Actually, it's not HTML, but it's a web page that shows you a great deal of verbose information, and it's kind of interesting to see anyway. Here, I'm just going to go ahead and create the cluster. And then as I click on Next through this, I'm going to add in the names of the servers, and we'll continue on. And so here you can see I've just gone ahead and entered in those names, and I'll go ahead and click on Next. Here I've also entered in the name of the cluster. Just call it cluster. Of course, you'll name it whatever makes sense for your environment. And then I've given it the cluster address of 10.10.10.64. Similar to network load balancing, it's going to be identified by that IP address, even though multiple hosts will actually be able to be reached through it. And then we'll go ahead and click on Next, and it's going to go ahead and create a computer object in Active Directory for cluster. That'll be the name of the Active Directory computer object. And then we see that these two nodes are there, and it's going to be referenced by the IP address that you see there. And then when you're done, it's created the cluster. Now, I don't quite have everything that I need here because I never set up any storage. You don't do that in the initial part of this wizard. Also, it says that no appropriate disk could be found for the quorum disk. We're going to see that we actually can do that, though, here. So the reason why it doesn't find any right now is because I haven't given it any. So I'm going to go ahead and go to Computer Management, and then we're going to go ahead and add those disks. And before I even go to Computer Management to add those, I also need to identify them or connect to them using iSCSI in this case. Let me just quickly run this down. I'm actually using something called SoftWind from Rocket Data, but if you go to rocketdata.com, you can download a free test version of this product. But although the exam doesn't actually cover this in particular, what I want to point out with this is how I'm going to be able to use network storage, but I'm going to connect to it as if it were locally attached SCSI devices, which allow me to treat it like a local device, even though it could be miles away in some other server room somewhere. Okay, but I'm going to also start the iSCSI service, and I'm going to make exceptions in the firewall for this as well. And then that's what this is here. I need to open it up through the firewall so that I can access it. Now what I want to do is to go to Discovery, and I'm going to add a portal, and this is going to be the IP address of 10.10.10.30 where that storage is located. This is the default port, and I'm going to leave it as that. And then on the targets over here, as soon as I go over here, these now will appear. All I have to do then is to log on to each one of those, and I'll just log on to them. Okay, and then that's pretty much it. I'm also going to have it be persistent so that it also always accesses those. Once they've been logged on to, now under disk management, I should see those disks. And let's go ahead and take a look here once this warms up. And so here we are. Now when we take a look at this, these are both offline, that's alright. This smaller one I'm going to use for quorum data. This is going to be for my actual data. Okay, so I'll just bring it online, bring this one online too. If it lets me right click on it. And we'll bring this one online here as well. And then once I've done with that, I can go ahead and just format these as necessary. I'm going to go ahead and just do all that quickly offline, and then we'll add them to our cluster. All right, then, having formatted these, then I've got cluster data on E and witness for drive, on drive W. Try to correlate that whenever I can. And then here I've got my cluster configuration. I'm going to go ahead and just expand this out. We can see here that we've got our nodes here, but we don't have any storage. That's the key right now. We don't really have a proper cluster until we have a storage. And in fact, you might have seen some warnings and stuff like that as we were getting started. And that's one of the problems. I got to add a disk. So I click on Add Disk. It says no disks were suitable. Uh-oh. Well, the reason for that is probably because over on cluster 2, I didn't connect them yet. So actually what I did here just a moment ago was I paused recording, went over to cluster 2, and just quickly went back in here and I did the same exact thing. You got to go to iSCSI, make sure that iSCSI is started, and then I added the disks back in here. Now notice the drive letters don't match. That doesn't really matter for the time being because we're going to go ahead and go back over here and add the storage in, and it should all be fine once I add this up, or start this up. So here I'm going to go back and add a disk. And this time we see some eligible nodes, or eligible disks. So here I'm just going to add both of these, and I'll just click OK. Of course, you just checkbox whatever is useful for you. And that's pretty much it. Now it brings those disks online, and I could do a number of different things with this. I could now use those drive letters to create a file share. I could use those to store data for my database for my DHCP, for WINS, for SQL, whatever it is that I needed to do. And then if one of these servers failed, the other one would fill in. Now also I want to point out, I kind of told you that the drive letters didn't really matter over on cluster 2. Why is that? Well, this cluster 1 is the main node, is the active node right now. And over on cluster 2, if I go back over there, we're going to see a difference in the way the drives look. They say reserved. That's because it's not actually using these disks, and it's kind of prevented from doing so, in fact. Because remember, you don't want two servers running to the disk simultaneously because of the potential synchronization and conflict problems that could occur. So if cluster 1 failed for some reason, then cluster 2 would come back on, and it would then resume these disks, and we'd be back in business. Now then, switching quickly back over here to cluster 1, let's just go ahead and take a look at a couple of other things. Number one, look at our quorum configuration. We're getting a warning on that. If just one of these disks fails, they actually the whole cluster would fail. And the reason for that is because I'm on node majority. And that's a quorum configuration that specifies that if the majority of the cluster fails, then the whole cluster comes down. Well, I only have 2, so it's kind of hard to define a majority with just 2. If I had 3, then this might be a recommended configuration, but as it is, that's not going to work. So what I might have to do here is to go to more actions here actually, and choose Configure Custom Quorum Settings. And then this gives you a little introductory page, and then I could just change that here to node and disk majority. So it could sustain a failure of one node in this case, and some of the rest of these are self-explanatory. So then I would just simply click on Next here, and again I would set the storage volume that I want to assign as the disk witness, because even though the volumes are available right now, they haven't really specified which one's which yet, and that would be drive W, so that would be my witness. And then I'd click on Next, and now we're pretty much ready. And it goes ahead and configures it all up for me, and it's just as easy as can be. There we go. We're now in business. Okay, now I've switched over here to cluster 2, and why did I do that? Well, because I can't show you cluster 1 anymore. Why? Because I disconnected the network cards in VMware. So it's basically the same as unplugging the network cable, and now cluster 1 is disconnected from the network and offline. Notice what happened over here in cluster 2, though. These came up automatically. I didn't have to fiddle with them or assign a drive letter or figure out a way to make it work. Over here in Failover Cluster Manager, also, it just identifies now that cluster 1 is down, and it just automatically brought cluster 2 on as being able to provide service now. And I didn't have to figure out a way to make it happen or trick it into happening or reconfigure or rejigger or otherwise fiddle around with it. It just does it by itself. Now what we see going on here is you see there your little hourglass, now it pops up. I had plugged back in the network cable, and now cluster 1 is back online again. Notice this, however, if I go back to Server Manager, and even the disks are still alive there on cluster 2, even if I rescan the disk or refresh, we're still going to see these disks here. And why is that? Well, it's because when clustering fails over to the passive node and the original active node comes back on, it doesn't make it active automatically again. So it just has switched the role now. Now cluster 2 is active and cluster 1 is passive. So if I really insist on cluster 1 being the active one, maybe it's more hardware capable or something like that, then I would have to force that to happen. And in most cases, clustering, you're going to have the nodes of the cluster be pretty well equivalent in terms of their hardware capability anyway, so it probably doesn't matter for most purposes. Now, I also haven't set it up for any services or applications, so I can right-click on Services and Applications, choose Configure a Service or Application. As I click next through the wizard, I'll identify what I want it to do. Maybe I want it to be a file server, or any of these other things. A lot of different options here. And then as I click on Next, it's also going to have now another name that will appear, and this is going to actually create a computer object called cluster FS. If I leave it that way, you can type in whatever you want to. And let's make this one, 65, I think, and click on Next. And then now we're going to have a computer object in Active Directory called cluster FS, and I have to identify what storage that is, and it's going to be on my drive G in this case. And I click on Next, and that's pretty much going to be it. Once I click past Next here, then it's going to make it available for clustering file services. And now let's continue and quickly talk here about operations masters as we continue the discussion of business continuity. This is very important that you have one of these operations masters online. These also used to be known as flexible single master operations, or FSMOs, which is what I usually still call them, a FSMO role. And we have 5 of these. There's 2 in the forest, and there's 3 in each domain in the forest. So for the forest, for example, I have the domain naming operations master role, and this is to make sure that when I install a new domain, I don't already have a domain by that same name in the forest. Well, the domain naming master keeps track of that, so that if I tried to create another domain called west.nugalab.com, but it had already been created earlier, then the domain naming master would be able to send a message saying, hey, you can't create that because somebody else already created that domain. I'm sure it's not quite that conversational or that friendly, but anyway, it gives you that message, and so that's why, because you have the domain naming master. And then the schema master is pretty much the skeletal structure for all Active Directory objects and attributes. All of the various fields, checkboxes, drop-down lists, radio buttons, all that stuff that you can fill out, for example, for a user account, well, that comes out of the schema. So this is, of course, architecturally critical for the entire forest. For each domain, you'll have the infrastructure master, which is responsible for checking cross-domain references for things like group membership. So if you have a user inside of a group, inside of another group in a different domain, well, it needs to be able to keep track of all of that, and it does so with the infrastructure master. And then the RID master is useful for doling out unique identifiers for each object, such as computer objects or users and groups, because they all actually have a SID, and I've gone ahead and done this in advance. But here, if I do a whoami/all, then we can see that this user account has this SID, and the first few characters here, up to the 21, are just Microsoft defaults. This middle section is unique, so that no 2 domains in the world should ever have the same 2 numbers here. It's supposed to be computationally impossible for them to both randomly generate the same number. And then this identifier at the end, that is what's doled out to me from the RID, or the relative master. And what happens is the RID master doles out a sequence of numbers to each domain controller, and then when the domain controller runs low on those because it's created enough accounts, the RID master will issue out some more. That's what the RID master does. And then the PDC emulator has quite a few different things that it does. First of all, it used to be back when you'd have NT4 domain controllers, it acted like the PDC emulator, or rather the PDC for NT4, and NT4 would think that it was a PDC. There are also applications that may depend upon trying to find a PDC in the environment. So NT4, since we don't really have that in Windows Server 2008 anymore, that's not quite as relevant, but you might have some older applications that want to try to find a PDC. And then it's also the password authority. Let's say that we have 3 domain controllers, okay, right here. And I've got a user here who logged onto this domain controller, and then they changed their password on that domain controller. Okay. Then they go to, across the campus to another domain controller, and they're closer to this one. So now they log on, and they try to log on using this domain controller, but it hasn't received this password synchronization yet. So it doesn't know that this user changed their password here. So when they try to enter in their password, it thinks that it's a bad password, but it doesn't reject the logon. What it does is it contacts the PDC emulator, and it says, hey, did this person change their password? Now, how would the PDC emulator know? Well, when we change our password on any domain controller, it immediately will send that password change to the PDC emulator, so we can guarantee that it always has the most up-to-date passwords. So then this domain controller here will say, is that the right password? this domain controller will say yes it is, user can log on. So it's the password authority for that. It's also the group policy object, not the authority, but it's going to be where you edit group policy. So anytime you edit group policy, even if you logged on to a different domain controller, it's actually the PDC emulator that's going to be showing you those group policy objects. It's also the domain master browser. This is mostly useful for things like network browsing and applications that depend upon single label names. But the master browser is responsible for collecting other computers that are, browsable or findable or discoverable on the network. And it's also the master time source. All other domain controllers receive their time from the PDC emulator in the domain, and then all clients that log on to their respective domain controllers will receive their time from their own domain controller. So since it starts at kind of the PDC emulator role here, then it flows down to all the other domain controllers and all of the clients and workstations that log on using a domain controller. Alright then, the key thing to remember for the 70-647 exam as it relates to flexible single master operations roles and business continuity is that we must always have all 5 of those roles online. So for business continuity, if one of them failed or if we need to transfer the role, you need to know how to do those things. It's also very useful to know which server it is that actually has those roles. So if I do and there's a number of tools that you can use to find that out. This easiest one is probably netdom query FSMO. Okay, and by doing that, I see that all of these roles are located on this one domain controller of DC Nugget 1. What if I wanted to transfer the infrastructure master back over to DC Nugget 2? How would I do that? Well, I would go to, actually I could go to DC Nugget 2. I could go to DC Nugget 2 itself, and that would be one way to do it. Or I could go up here and I could connect to a different domain controller. So I could, for example, right now if I choose Operations Master, and I'm trying to move over this infrastructure master role, I can see that right now there's no way to transfer it because I don't transfer it from one to one. So there's nothing I can do really with that. So what I'd have to do is I'd connect to that other domain controller, or change domain controllers, and I would choose domain DC Nugget 2. Now that I'm connected to DC Nugget 2, and you can kind of see in the tooltip item there that I am connected to that one. Now when I choose Operations Masters and Infrastructure, notice that I can now change it this way, because there's 2 different servers listed there, so I choose change. Are you sure you want to do this? There's a brief warning here saying that I shouldn't transfer it to a server that's also the global catalog server, but I'll choose OK for the time being there because I'm going to change it back anyway in a moment. And then now my infrastructure master is located on DC Nugget 2. Now let me go ahead and change this back again before I forget to DC Nugget 1. Now, what other way could I do this? Well, I could seize the role, and this would be useful if I had, if the server had gone down hard and we couldn't bring it back. Maybe the hard drive just totally burned out or something, and we could never bring back that particular domain controller. Now the thing here is I would need to seize the role. So it's already on DC Nugget 2. The infrastructure master role's on DC Nugget 2. Now what I would need to do is to go to ntds util, and notice here that I'll click on continue here. Notice that I am on DC Nugget 1. That's the server that I'm currently connected to, and that's where I am. Okay, so I'm on DC Nugget 1 and I need to seize that role. Then I'll enter in roles from the ntds util command prompt. From the FSMO maintenance role, I'll type connections. Okay, and this is just how I'm going to seize the role. And then I'll choose connect to server, and then the fully qualified domain name of the server. So that would be dcnuggets1.nuggetlab.com. Okay, and I'm connected to it now. Then what I would do is I would just type quit because I'm connected to it now. And then, because I don't have to do this anymore, I'm already connected to DC Nugget 1. Then what I would have to do is to seize that role. So I would choose seize infrastructure master. Did I spell all that right? Infrastructure master. Okay, I think I did. Okay, and then I'll press enter. And it says, are you sure you want to seize that infrastructure master role? And it gives me the location to where I'm trying to seize it. And I'll say yes. And then we'll see that it transferred, the FSMO role transferred successfully. Seizure not required. What? Why did that happen? Well, that actually happened because when you try to seize the role for a server that is actually still alive, you see DC Nugget 2 is still on the network. So it was able to transfer it gracefully without being too heavy-handed and seizing that role instead. Whereas if DC Nugget 2 were actually down permanently and was not on the network, then it would actually seize that role. In this nugget, we discussed business continuity, or continuing your business. One of the ways to do that is to make sure that you have high availability for your web servers or any other kind of a server that can implement network load balancing. This means that you're going to get a high level of performance. Remember, with network load balancing, you don't have shared storage like you do in clustering. And this is where we're going to have data that changes rapidly and often, such as SQL, email, such as Exchange servers, other things of this nature. And we talked about both of these and how they operate. We also took a look at operations masters. Remember, those are critical roles, and you really can't do without those, at least not for very long for some of them. So you need to make sure that you know how to transfer the role to a server that's more suitable, or how to seize the role if the original role holder goes down. Well, I hope this has been informative for you, and I'd like to thank you for viewing.